Well, here we're back at worksheet number 4, the last two problems, number 6 and 5. So this one, we have an ice cube tray full of ice at minus 7 degrees and allowed to warm up the room temperature at 22. And how much energy will be absorbed by the contents of the tray in order for this to happen. So again, let's do our graph. So put our graph in here. And we've got time. Again, we have temperature. Okay, we've got the ice at a minus 7, so we got to warm it up to 0. And so then we got to melt it, and then we're going to warm it up to 22 degrees. So really, we got a 3-step problem on this one. So let's do the first one. We got solid ice, and we've got to get it up to 0. So let's call this Q1, and we know that equals MC delta T. So Q1 equals, we've got 235 grams. We know C, the heat capacity of solid water, is 2.1 joules per gram degrees Celsius. And we're taking from a negative 7 to 0, so that's 7 degrees Celsius. So if we do the math, Q1 equals 3,454 joules. Alright, next thing we got to do is melt the ice. So let's call this Q2, and it's going to be mass times the heat of fusion. So Q2, the mass does not change, 235 grams, and we know the heat of fusion is 334 joules per gram. So Q2 equals 334 times 235, so it equals 78490 joules. So that's Q2. Now we got to take that melted ice and take it up to 20 degrees. Or 22 degrees, excuse me. So let's call that Q3. And so we got MC delta T. So Q3 equals, mass does not change. We know liquid water is 4.18 joules per gram degrees Celsius. And we've got a change in temperature from 0 to 22, so it's 22 degrees C. So Q3 equals 21610 joules. Well, let's go ahead and add Q1 plus Q2 plus Q3. And if we add all those together, if my math is right, it's 103,554 joules. So that's problem 6. So that leaves us with one more problem to do. And let's look at problem 7. Get a piece of paper in here so we can work. And problem 7 states that the same quantity of energy were removed from 40 grams of water vapor at 100 degrees Celsius. What would the final temperature of the water be? Alright, let's draw our little graph again. So we got time, and we got temperature. So we got some stuff at 100 degrees C, so we want to remove it from water vapor. What will the final temperature of the water be? So we know that temperature is going to decrease. So first thing we have to do, we have to condense And we're going to call this Q1, and it's M times the vaporization. So Q1 equals, and let's see, we have 40 grams, and we know the heat of vaporization. That's 2260. Oops, forgot the grams. Joules per gram. So Q1 equals 90,400 joules. Well, we're going to use the same quantity that we had from the previous problem. So we were given that we have 103,554 joules. We used 90,400 joules. So there are 13144 joules left. So we want to see what's going to be the final temperature with that much energy. So Q2 equals MC delta T. So Q2, we've got that much left. 13144 joules. The mass isn't going to change. We got 40 grams. We know the specific heat of, or the specific heat capacity of liquid water is 4.18 joules per gram degree Celsius. And we don't know where the final temperature is going to be. So if we do the math, we got delta T is 78.6 degrees. Well, we want to know what the final temperature of the water is going to be. And we started at 100, so this would have been 100 up here. So our final temperature is going to be 100 degrees Celsius minus 78.6 degrees Celsius, which is 21.4 degrees Celsius. Oops, let me get that above there a little bit. Sorry about that. So that's where we're at, and that ends this worksheet.